Please label your paper one-step equations. The standard is 7EE4. And today's date is February 4th. The key words for this lesson: equation, a mathematical sentence that contains an equal sign showing the two expressions are equal; solution, a value for the variable that makes an equation true; an inverse operation, an operation that undoes another. The inverse operation for addition is subtraction. The inverse operation for multiplication is division. Therefore, the inverse operation for subtraction is addition, and the inverse operation for division is multiplication. It is very important that you watch as I solve for C. So I'm going to go ahead and rewrite the problem. C minus 5 equals 6. And the first thing I'm going to do is I'm going to circle my variable, and I am going to bring down this equal sign, which is going to also be my wall. Now the reason I have a wall is because whatever I do to one side, I have to do to the other. So if you look right here at the subtraction sign, I'm going to do the inverse operation of that. So it tells me to subtract. So the inverse of subtraction is to add. So I'm going to add. And the reason I have this wall here is because I want to add on both sides of the wall. Now the whole point is to get C by itself. So negative 5 plus 5 ends up giving you 0. So this cancels out on this side, and you're left with C plus 0. Now, do you need the 0? No. So I'm just going to put C. C equals. And then I come on this side of my problem, and I go ahead and I add. 6 plus 5 is 11. And then I'm going to box this in because now I have completed this equation. Now the last thing I want to do is I want to check to make sure my answer makes sense. So if I plug 11 back in where C is, and I write this problem as 11 minus 5, and I ask myself, what is 11 minus 5? And that gives me 6. If this answer is the same as this answer, then you have a correct problem. So this time we are going to solve an addition. So I'm going to rewrite my problem. D plus 4 equals 5. And I'm going to go ahead and I'm going to circle my variable because this is what I want to be by itself. And I'm going to bring my wall down. And remember, I'm bringing my wall because whatever I do to one side, I have to do to the other. And I'm going to go ahead and put my equal sign. And then I look at what is next to the wall. It's the addition sign. And I'm going to do the inverse operation. So the inverse of adding would be subtracting. So I'm going to subtract 4 from both sides. And a positive 4 minus 4 ends up giving me 0, so that cancels out. And I'm left with D. Now, do I need to bring the 0 down? No. So now I have D equals. I come on this side of the problem, and I ask myself, 5 minus 4 leaves me with 1. So my solution to my problem is D equals 1. Now I need to check and see if my solution is true. So I'm going to plug this 1 back in where the D is, and I'm going to write it as 1 plus 4, and 1 plus 4 equals 5. And since this and this are the same, then I know that my sentence is true. On this problem, we're doing subtraction again. So I'm going to again rewrite my problem. D minus 6 equals a negative 5. I'm going to circle my variable because I know that that's what I need to get by itself. And I'm going to draw my wall with my equal sign. And then I'm going to go back up and I'm going to look. And next to the circle is a subtraction sign. And the inverse operation of subtraction is addition. So I know that since it tells me to subtract 6, I'm going to add 6. And whatever I do to one side, I have to do to the other. So I'm going to add 6 over here. So a negative 6 plus a positive 6 cancels each other out because you end up getting 0. And I'm left with only this D. So I'm going to go ahead and bring the D straight down. And I notice I leave it on the left-hand side of the wall because that's where it started. And then I'm going to come back over on the right-hand side, and I have a negative 5 plus 6. And negative 5 plus a positive 6 gives me a positive 1. And that is my solution to this equation. Now I need to check my solution to make sure that it is a true sentence. So in order to do that, I'm going to plug 1 back in here, and I'm going to rewrite it as 1 minus 6. And if I go back and think about the rules for adding integers, I know that I always change the minus to a plus and change the sign of the next, or keep, change. And I have a 1 plus negative 6. Take the sign of the larger number, and then I'm going to subtract. 6 minus 1 gives me a negative 5. If this is the same as this one, then I have a true sentence. My last example is C minus negative 4 equals 6. And I know from the rules from the beginning of the year on integers, I have to keep, change. So now I have that I am adding a positive 4. So remember, we're going to circle our variable, and we're going to draw our wall, bring down our equal sign, and then I'm going to do the inverse of adding 4, so I'm going to subtract 4 on both sides. A positive minus a negative 4 cancels out, and I'm left with C. And then 6 minus 4 leaves me with 2. And that is my solution for this equation. Now I want to check it. So I'm going to take the 2 and plug it back in where the C is. And I have 2 minus negative 4, since that was my original. Keep, change. And I have 2 plus a positive 4, which gives me 6. If this matches this, you know you have a true statement. Here are a few examples for you to try on your own.
Bye, Felicia.